Hello, everybody.
We're going to drop 2 rolls of toilet paper and make them hit the ground at the same time. One roll will simply be dropped and the other will be unraveled.
Using rotational dynamics and kinematics equations, we can calculate the ratio of the heights that the rolls must be dropped from in order to reach the ground at the same time. Due to conservation of energy, we know that all the potential energy due to gravity will be converted into either translational kinetic energy or rotational kinetic energy.
Roll A will be the drop roll and roll B will be the unraveled roll. We're going to drop roll A from 1.5 meters above the ground, and then we'll calculate how high to place roll B in order for them to reach the ground at the same time. To start out, we'll write down all the equations we'll need for this. Since we're using a roll of toilet paper, moment of inertia is equal to 1/2 the mass times the sum of each of the radii squared.
We'll also need some measurements. We measured the toilet paper to be 0.227 kilograms. The outer radius is 0.11 meters and the inner radius is 0.04 meters. We solved the moment of inertia to be about 1.55 times 10 to the negative third kilograms meters squared.
We'll begin by writing down our givens for roll A. Since it's being dropped from rest, the initial velocity will be 0 meters per second. The acceleration of the toilet paper is due to gravity, so it's 9.8 meters per second squared. We chose to drop roll A from 1.5 meters above the ground.
We solved for velocity and ended up with 5.42 meters per second.
Using the final velocity, we can solve for the time. We find that the time is 0.55 seconds.
We come to the conclusion that time is the same for both rolls of toilet paper since they hit the ground at the same time.
We can now use this time to help solve for roll B. We'll start out by writing the givens once again, and this time we'll use conservation of energy.
Using conservation of energy, the initial potential energy converts to translational and rotational kinetic energy. We will begin by plugging in the variables. The height in this case is delta x, which we know is equal to the product of the average of the velocities and time.
We can replace omega squared with v squared over r squared.
Next, we factored out a 1/2 v squared from the equation. Finally, we plugged in our known values to solve for the final velocity of roll B. We found the final velocity of roll B to be 3.45 meters per second.
We use the kinematics equations to solve for the height of roll B, which is 0.949 meters.
We have found the respective heights at which to drop the rolls to reach the ground at the same time. To find the ratio, we will divide them.
After dividing the 2 heights, we find the ratio to be 1.581.
Now that we have the ratio, we're ready to test out our math. Let's see if physics works. We'll drop roll A from 1.5 meters above the ground and roll B from 0.949 meters above the ground.
As you can see, both rolls landed at almost the exact same time. This proves that conservation of energy applies to even rotating objects. 1, 2, 3.
Hello, everybody! Oh my God. My friend Zarah has left me over here by myself.
Working the roadblock.
Let's see if physics works!
Welcome to our
Actually, this is the bloopers that Mr. Howard wanted to see, so here you go.
As you can see, both rolls landed at almost the exact same time. This proves that conversation.
Ready? 1, 2, 3. Extra credit physics project!
As you can see, conversation!
Conversation?
As you can see, we can.
Mr. Howard, we have a new physics topic.
Conversation of
energy.
Where we talk about energy. Would you like that?
Oh my god!
Oh!
Due to I hate Invisalign. Now that we have the ratio, we're ready to test our math. Let's see if physics works. Okay.
We can calculate the ratio of heights that the rolls must be dropped from to reach the ground. That's movie magic. And one will be unraveled. Using... So we have our toilet paper here ready to go. This is the premium 2-ply stuff. Perfect for testing gravity.
Okay, good.
We're gonna drop 2 rolls of toilet paper.
Play.
Okay. Let's
business to defeat the hunt. What? Due to
I have to regain my composure. Rotating objects.
What a trip!
The dropped roll will be roll A, and we'll start dropping it
From
and using the knowns from that math set. From that set of math.
We can calculate the ratio of the heights of that.
Thank you, world, for allowing conservation of energy for us calculate things.
Also,
math.
Thank you, gravity. Also, thank you for Newton. From those numbers in math. Thank you for watching our video. We hope you enjoy. We love physics. Physics works, and we prove it.
Physics.